So, okay, today the topic of discussions will be related to the metacenter and what is metacentric height, how to determine the metacentric height with respect to any object which is partially immersed inside a water surface. So, it has got a linkage with respect to the buoyancy. So, it is an advanced topic related to the flotation part. Metacenter is nothing but it is a point with respect to an object where the object starts to oscillate when it is given a slight disturbance or when it is given a slight oscillation. So, or else we can also define this as the point at which line of action of the force of buoyancy will meet the normal axis of the body when the body is given a small angular displacement. As you see this diagram, if the object was not given any displacement, then the point of buoyancy would have been present at this point. Since the object is given a displacement, so the body is going to start oscillating. That is, the body is going to incline to certain angle, but the CG point doesn't change. The CG is going to remain at the same, but the center of buoyancy is going to shift to a certain point. As you can see in this diagram, the B has shifted from this normal axis. So when this B is traced back to this normal axis line, the intersection point with respect to the normal axis and the center of buoyancy, we call it as the metacenter. It can also be defined as it is the metacenter is the point of intersection with respect to normal axis and the center of buoyancy. So nothing but when an object is just given a displacement, that means if the object is tilted, the center of buoyancy is going to shift, but the center of gravity is going to remain with respect to this normal axis. So when the center of buoyancy is going to trace back to this normal axis, the point of intersection of the normal axis and the center of buoyancy is nothing but the metacenter. So M represents the metacenter point and GM represents the metacentric height. So as you can see in this diagram, GM represents the metacentric height, M is the metacenter point, G is the center of gravity, and B is the center of buoyancy. So metacentric height is given by the formula Gm is equal to moment of inertia with respect to y-axis divided by volume of the submerged body minus Bg. B represents the center of buoyancy and G represents the center of gravity. For example, in a rectangular object, let us assume the center of gravity is 0.6 meter and the center of buoyancy is 0.4. The difference between the center of gravity and center of buoyancy is Bg. So this is the formula which is used to calculate the metacentric height. As I said, moment of inertia with respect to y-axis. For example, we know moment of inertia of a rectangular object with respect to x-axis is Bd cube by 12. Similarly, moment of inertia with respect to y-axis can be written as dB cube by 12. And V is the volume of the submerged body and Bg is the difference between the center of gravity and center of buoyancy. As I said, metacenter is a point with it is an intersection point with respect to the normal axis. This is the normal axis I can see, which is an inclined one, and it is the point of intersection of the normal axis and the center of buoyancy, which is traced back. As I said, when a body is given an angular displacement, the CG is going to remain at the same point. The only changeover point is center of buoyancy. When this center of buoyancy is being traced back towards the normal axis, the point of intersection will be called as metacenter. And metacentric height is calculated by the formula Iyy divided by V minus Bg, where Iyy is the moment of inertia along y-axis and V is the volume of the submerged body and Bg is the difference between Cb is the center of buoyancy and Cg is the center of gravity. So I have taken two different examples to calculate the metacentric height. The first problem is a rectangular pontoon is 5 meter long, 3 meter wide and 1.2 meter height. The depth of immersion of the pontoon is 0.8 meter in seawater of so and so density. If the CG is 0.6 meter, CG represents the center of gravity above the bottom of the pontoon, find the metacentric height. He is saying it is a rectangular pontoon. It is nothing but it is a partially submerged body, or we can say it is a boat. It has the dimensions of that pontoon is 5 meter long. The length of that pontoon is 5 meter long. The width of the pontoon is 3 meter, and the height, or we can also say the thickness of the pontoon. The thickness of the pontoon is 1.2 meter height, and is also given the depth of immersion of the pontoon. So H, the small h parameter, is already given. You can remember in the yesterday class while calculating the position of the buoyancy, we used to calculate the h. H is nothing but it is the depth of immersion. So is already given the depth of immersion of the pontoon, which is saying it is 0.80 meter, and it is immersed in seawater of density 1025 kg per meter cube, and is also saying if the CG is 0.6 meter above the bottom of the pontoon, from this depth the CG is 0.6 meter, is going to is asking us to determine the metacentric height. As I said, metacentric height is given by the formula Iyy divided by V minus Bg, where Iyy is the moment of inertia with respect to y-axis, V is the volume of object submerged, and Bg is the difference between the center of buoyancy and center of gravity. So you can see I have written the submerged view. That means if this is the overall object view, I have written the submerged view where I am taking he has given the width of the object as 3 meter, the depth as 0.12 meter, and is also saying the depth of the immersion is also he had only given that data. He is saying that it is 0.8 meter. If he has not given that data, we have to follow the procedure that we have done in the previous class. That is, we have to determine what is the weight of the object and what is the volume of water displaced. Using the volume of water displaced, we have to calculate the volume of the object, where the length and the breadth has been constant, and the only varying parameter is the depth of the immersion. So in this problem, the pontoon width is 3 meter, the depth of the object is 1.2 meter, and the depth of immersion is 0.8 meter. So the first parameter we have calculated is the volume of object submerged, that is V. It is nothing but 5 is the length, 3 is the width, and why I have taken 0.8 means, as the word says, it is the volume of the object submerged. We are not going to take 1.2 meter because it is the overall depth of the object, but only 0.8 meter depth has been submerged inside the water. Hence we have taken it as 0.8. So we have multiplied those three parameters and we have got the volume of object submerged as 12 meter cube. The next parameter is, he has already said in the problem, as you can see, if the CG is 0.6 meter above the bottom of the pontoon, he has already given you the center of gravity. That means in 1.2 meter height or in 1.2 meter depth of the object, the CG is around 1.2 meter, sorry, 0.6 meter. And since he has given the depth of the immersion, the depth of immersion is 0.8. From that, we are going to calculate the center of buoyancy or the position of buoyancy, which is nothing but half that. Half the depth of immersion is the center of buoyancy. I have used that. The depth of immersion was 0.8. I have divided by 2 and I have got the B value as 0.4 meter from the bottom. We know the CG, he has given us the CG 0.6 meter. He has given us this depth of immersion. Using that, we have calculated the position of the center of buoyancy. So it is 0.4. Next, Bg, as I said, it is the difference between the center of buoyancy and center of gravity. The Cg value is 0.6 meter. The Cb value is 0.4 meter. We have differentiated those two and the Bg value we are getting is 0.2 meter. And the last parameter we have to calculate is the moment of inertia with respect to y-axis. So this view, as I said, moment of inertia is always calculated for a two-dimensional object. So this view is the bottom view. That is, if you are submerged and if you are seeing the object, the breadth of the object will be 3 meter and the depth of the object is 5 meter. Or you can also say it is a top view. So you are only seeing a laminar structure where the width of the structure is 3 meter and where the length of the structure is 5 meter. So moment of this becomes a rectangular section. The moment of inertia for a rectangular section with respect to x-axis is BD cube by 12. But he has said we have to calculate the moment of inertia with respect to y-axis. It becomes dB cube by 12, where the depth of the object is 5 meter, the breadth of the object is 3 meter, and I have calculated using those three values, and I am getting the moment of inertia as 11.25 meter cube. So as I said, first differentiate what is the data he has given. First he said a rectangular pontoon is 5 meter long, 3 meter wide and 2 meter height. This is a rectangular pontoon which is nothing but a boat, where the length of that pontoon was 5 meter, the width of the pontoon was 3 meter, and you can assume this height as the thickness. It is 1.2 meter. He is saying the depth of immersion of the pontoon was 0.8 meter in seawater, and if the CG represents the center of gravity is 0.6 meter above the bottom of the pontoon, find the metacentric height. As I said, metacentric height is, it is the formula is given by Iyy divided by V minus Bg, where Iyy is the moment of inertia with respect to y-axis, V is the volume of object submerged, and Bg is the difference between the center of gravity and center of buoyancy. We have taken a 2D object, that is immersed depth we have considered, and the width of the object we have considered, where the width is 3 meter and the depth is 1.2 meter. Since he has given the depth of immersion directly, there is no necessity that you have to calculate the weight of the object or volume of water displaced. If you had not given the depth of immersion, then you have to add the center of buoyancy procedure. So since he has given the H value, that is the depth of immersion, calculate the volume of object submerged, where the length is going to be constant, the width is going to be constant, and the depth of immersion is given is 0.8 meter. We have used that and we have got the value as 12 meter cube. The next thing is to calculate Bg, which is nothing but the difference between the center of buoyancy and center of gravity. G has given the depth of the object was 1.2 meter. From the bottom, the G value is 0.6 meter. Next, center of buoyancy, the position of buoyancy is nothing but half the depth of immersion, where H has given it as 0.8. We have divided by 2 and we are getting B as 0.4 meter. So we have subtracted the center of gravity with respect to center of buoyancy, and we have got the Bg value as 0.2 meter. As I said, with respect to moment of inertia, you have to take it as a laminar structure. From the top view, if you are going to see the object, it will be like this, where B is 3 meter and D is 5 meter. It is a rectangular object. The moment of inertia with respect to rectangular object along y-axis is BD cube by 12. But here in this formula, we are going to use moment of inertia along y-axis. So it becomes dB cube by 12, where D is 5 meter and B is 3 meter. And we used the formula and we have got the moment of inertia as 11.25 meter to the power 4. So substitute all the three values in that, you are going to get the metacentric height as 0.74 meter. Sometimes in the problem, he might ask you, state the equilibrium condition. That means whether it is stable, whether it is unstable, or whether it's an equilibrium condition. If the metacentric height you are going to get it is a positive value, that means if you see this diagram, that means if you are going to get this GM as positive, that means the metacenter is going to lie above the center of gravity. If the metacentric height you are going to get is negative, then the metacenter, this M is going to lie below the center of gravity. If the GM is going to be 0, then the metacenter is going to coincides with the center of gravity. So simply we can say that stable means the metacenter, the GM value will be positive. Unstable means the GM value will be negative. Equilibrium means the GM will be 0. In this problem, we have got the GM value as positive. If they are going to ask you to determine or to comment on the equilibrium condition, we can say it is a stable condition. So another example is, I have taken a solid cylinder. He is saying a solid cylinder of dia 4 meter and height is 4 meter. As you can see in this diagram, the diameter of this solid cylinder is 4 meter. The height of the solid cylinder is 4 meter. Find the metacentric height of the cylinder if the specific gravity of the material of cylinder is 0.6 and it is floating in water with its axis vertical. As you see this diagram, it will be immersed as you are seeing like this only inside the water surface. State whether the equilibrium is stable or unstable. As I said, stable means if GM is positive, you are going to get it as a stable condition. If GM is negative, then it will be a unstable condition. So in term of a solid cylinder, as I said, the formula used to determine the metacentric height is same Iyy by V minus Bg, where Iyy is the moment of inertia with respect to y-axis, V is the volume of the submerged body, and Bg is the difference between the center of buoyancy and the center of gravity. So only the change with respect to the other problem and the solid cylinder is you can calculate the depth of the immersion in terms of a solid cylinder using this formula. That is, the depth of immersion will be equal to height of the object or the depth of the object multiplied by the specific gravity. This formula can be only applied for the solid cylinder condition. It cannot be used for any object such as pontoons or rectangular object. To determine the depth of immersion in terms of those objects, we have to follow the buoyancy procedure. But in terms of a solid cylinder, the depth of immersion can be calculated using this formula. That is, what is the height or depth multiplied that with the specific gravity. So in the problem, the depth of the object, that is the height of the object is 4 meter. As you can see in this diagram, the specific gravity is 0.6. So multiply those two parameters and you are going to get the depth of immersion as 2.4 meter. So the first parameter we are going to determine is the volume of submerged body. Once you know the depth of immersion of the object, you can easily calculate the submerged volume. So volume of a solid cylinder is nothing but area multiplied by your height. Since we have got the diameter as 4 meter, area pi d square by 4, multiply that with the submerged depth, not the entire depth. Since we are calculating the submerged volume, we have to use the submerged depth itself. So the submerged depth is 2.4. So the diameter of the object is 4. I have used these terms and calculated the submerged volume as 30.16 meter cube. Next, we have to calculate the Bg value. As I said, it is the difference between center of gravity and center of buoyancy. So since as I said, you are going to consider it as a laminar structure. H is the height. So Cg will be H divided by 2, half the height. So as you can see here, G is the center of gravity. It is we are going to consider as a laminar section. Therefore, the depth will be 4 meter. You're going to simply divide it by 2 and you're going to get G as 2 meter. Next is to determine the position of center of buoyancy. As I said, it is half the depth of immersion. In the first step, you have calculated the depth of immersion as 2.4 meter. Just divide it by 2. You're going to get the center of buoyancy. So CG is 2 meter. CB is 1.2 meter. So BG will be equal to 2 minus 1.2. That is the difference between the center of gravity and center of buoyancy. Therefore, BG value is going to be 0.8 meter. Then the last step is to determine the moment of inertia. The moment of inertia for a solid cylinder, whether it is with respect to x-axis or y-axis, the formula remains the same. That is, it is pi d to the power 4 divided by 64. In terms of rectangular section or in terms of a triangle section, the moment of inertia with respect to x-axis and y-axis might vary, or it is going to vary. But in terms of a solid cylinder, the moment of inertia with respect to both the axes, that is x and y, it is going to remain constant. That is pi d to the power 4 divided by 64, where I have substituted the d value, that is diameter he has given is 4, and we have calculated the moment of inertia as 12.57 meter to the power 4. Therefore, substitute all these value in your metacentric height equation, that is Iyy divided by V minus Bg, where Yyy I got is 12.57. The volume of the submerged body is 30.16 and the Bg value is 0.8. Here, the metacentric height you are going to get is minus 0.38. The sign convention is very important. If it is a positive, that means the object is in stable condition. If it is negative, then it is unstable condition. I said stable is nothing but the metacenter is going to lie above the center of gravity. If you are going to get a negative, the metacenter is going to lie below the center of gravity. These are the two important problems, because only in terms of solid cylinder, the only change you can see is the only important thing that comes into the picture with respect to the solid cylinder is the depth of immersion can be calculated using this formula. It is only restricted with respect to solid cylinder. It cannot be used in a wooden block, or it cannot be used in a pontoon problem. So the procedure is simple. First, you have to calculate what is the depth of immersion of the object. Using that, calculated the submerged volume. Then look into the object type, whether it is a pontoon, or whether it is a whether it is a rectangular lamina, or whether it is a circular lamina. If it is a rectangular or a triangular, as I said, the moment of inertia is going to vary. Since in this problem it is a solid cylinder, the moment of inertia formula with respect to x and y has remained constant, that is pi t to the power 4 by 64. And then always the cg value, sometimes he might be given you the cg value, or sometimes he might not give you the cg value. Since it is a solid cylinder, the depth we are going to take it, sorry, the height we are going to take it as 4 meter. The 4 meter you are going to divide it by 2, that will be the center of gravity. And once you know the center of gravity, calculate the position of the buoyancy. That is, whatever the depth of immersion, just divide it by 2, you are going to get the point of buoyancy. Then subtract the center of gravity with respect to buoyancy, you are going to get the BG value. So substitute that in your metacentric equation, you are going to get the metacentric height. If they are going to ask you to comment on whether it is a stable or unstable, if this GM value is positive, it is a stable condition. If GM value is negative, then it will be an unstable condition. So this is regarding the metacentric